Hey everybody, and welcome to TrainSignal. We're going to talk about transaction logs and recovery models. Now these two features go hand in hand in SQL and in your recovery scenario. You can't have one without the other, and it's actually the recovery model that defines how the transaction log works. Let's go ahead and take a look at what a transaction log is. So what a transaction log is it's a log file, or a data file actually, that just holds log data. And it keeps track of all the database changes. So anytime you update a table, or you insert data, or you delete anything, all of that goes into the log. And the reason it puts all of this in the log is so that you can roll back or roll forward transactions during a recovery scenario. And recovery doesn't necessarily have to mean your database goes down. You could just want to roll back a transaction. So let's say, for example, that you have an explicit transaction, and you want to insert data into one table and delete data from another table, and you want both of them to complete in their entirety, or you want nothing to complete. So in other words, you want the inserted data to be inserted and the delete data to be deleted together. You don't ever want the insert to complete and not the delete, or vice versa. If one of them goes, they both go. And if one of them fails, then they both fail. That's what a transaction is, right? You're defining a discrete amount of work that completes as an entire entity, and either the whole thing passes or the whole thing fails. So if you had one of these explicit transactions, and the insert passed, and then the delete failed, well, you wouldn't be able to roll back the actions of the insert if you didn't have a log of what you did. If SQL didn't record what you did in that insert and in that delete, then you wouldn't be able to roll back. You would have an incomplete transaction. So you can see you don't have to have a full recovery scenario to take advantage of this. You use it all the time when you do any kind of transaction whatsoever. And all of these changes that you make, say if you delete records from a table, all of these deletes are written to the log first before they're written to the table. And that's called write-ahead logging. And think about it, that's really the only way to do it. If you recorded it to the table first, or to the data file first, and then to the log, what would happen if you had some kind of server failure, hardware failure, right? Between the time that you wrote it to the data file and before the log file was written. So what you would have is you would have data in a table and no log of it actually happening. So if you had a major failure, SQL wouldn't know that that transaction even existed. So by writing to the log first, if you do have some kind of failure like that, you can either roll back the transaction because all of the details of the transaction are in the log, or you can go ahead and roll the transaction forward, which means go ahead and apply it to the data file. The log activity is actually defined by the recovery model that you have, because honestly, you really won't have the same level of logging for every single operation. Let's say that you're inserting, that you've got a really strong OLTP system, and you're inserting, just one or two rows at a time. Maybe you're doing it by, 5,000 users, but each one of those users is only inserting, a couple, 3 or 5 or 10 rows at a time. Well, it's really easy to have full logging turned on, and full logging means that it's going to log all the details about every single row that you insert. So if you insert a row into customer orders, it's going to insert all of that customer data into the log. But if you've got like a reporting system and you're going to be inserting millions or hundreds of millions of rows, you don't want the details for every single row to be inserted in the log, because not only is that just going to be a huge log, but it's really going to slow down your insert to have to log all of the details of every single one of those. So when you put it in full mode, all of the details of every single row of every single transaction gets recorded in the log. And that's how you're able to get your point-in-time recovery from your full mode, because if a transaction takes, like if you've got a large transaction and it takes an hour to complete, so let's say it goes from 4:30 to 5:30, point-in-time means that when I'm recovering and I'm rolling through the logs, I'm able to say stop at 5 o'clock, or stop at 5:02 in 10 seconds, something like that. And the same thing with the smaller transactions. It gives me the ability to have the detailed information for each row. If I'm only inserting 5 or 10 rows, and that happened at 5:01, and I don't want those rows in the database, then I can say restore up to 5 o'clock and just skip that last minute's transactions. So that's what point-in-time recovery means. Now, bulk load, it doesn't allow you to do point-in-time recovery because it allows you to define bulk load transactions. And those bulk load transactions are what I was talking about a second ago when I was talking about transactions that don't have every single detail of every single row recorded in the log. It does record something to the log, but let's take the scenario where I'm trying to insert 500 million rows. I don't want every single detail logged in the log. All I want is a very super fast load because maybe it's coming from a text file or from another system. In fact, it's likely, right? And so in that scenario, it's much more important for me to load that data really fast than it is for me to be able to recover the entire thing. I can just rerun my process if I have a failure in the middle of it. So in that case, the only thing that gets logged to the transaction log are the page allocations. The only thing SQL says is, hey, I created a new page, I created a new page, I created a new page. That's the only thing that it's concerned with. It's not concerned with the details of the transaction. And that not only cuts down the size of your log tremendously on those large loads, but it also greatly speeds it up. So clearly you couldn't have point-in-time recovery during something like that. So let's take the same scenario. You've got a large transaction that runs from a large insert that runs from 4:30 to 5:30. You couldn't say stop at 5 o'clock if you were going to restore from a transaction log, because the SQL has no idea what was actually going on at 5 o'clock. All it knows is that this one page was allocated or this one extent was allocated. It doesn't know the details of what was going on. So that would be an incomplete transaction. There's no way that SQL could recover from that. Now, both bulk logged and full mode require you to take log backups. If you don't take log backups, then the log is just going to get bigger and bigger and bigger. So, okay, now the question becomes, how do you decide which recovery model to use? Well, it's actually not that complicated. If you need point-in-time recovery, or you need to be able to capture every single transaction, every detail of every transaction that comes across, the only way to reliably do that is with the full mode. Now, I say reliably because in bulk mode, you can also grab every single detail of every single transaction, but just know that minimally logged transactions like bulk loads or re-indexing, stuff like that, will be minimally logged. Now, it may be that you don't want any of those, so you'll be just fine. But know that if you've got your database in bulk load recovery model and you don't have any bulk transactions, then you can still have point-in-time recovery. But if you have any bulk load operations at all, including like a re-indexing, even the transactions you have that weren't bulk load, that were regular transactions, you don't get point-in-time recovery anymore in that log. So that's why I say that full mode is the only reliable way, because it will fully log everything regardless. Whereas bulk mode, there's a little bit of nuance in there. If you have a bulk operation in there, you can no longer have point-in-time recovery. But if you don't have any bulk operations, then you can get point-in-time recovery. And quite often, I'll put my database into bulk load just for the reindexes. I'll switch it to the bulk mode just for the reindex and then switch it back. Also, in the full mode, your log is just going to grow and grow and grow until you take a log backup. You absolutely have to take a log backup in order to shrink your log. And I'll talk about that more here in a minute when we go to the demo. Now, the one thing we haven't talked about so far is simple mode. And simple mode is a lot like bulk mode, with the exception that you can't take log backups. Simple mode is simply you don't want to save anything at all. Any transaction that comes in as a bulk mode operation will be minimally logged like it was in the bulk load, but when any fully logged transaction completes, it'll also be overwritten in the log or flushed from the log. So that's why you can't take any log backups in the simple mode, because they're constantly being overwritten. I don't care about recovering any of the transactions. All I want to do is take full backups, and maybe that's full backups every day, maybe that's every week, but you really don't care about what happens throughout the day. You just want to go between full backups and just not lose everything. So these are really for very unimportant databases, a lot of times test or dev boxes. or maybe even these third-tier applications that just don't have a lot of activity, so it's really not much to go back in and enter in a few records if something happens. Okay, now we're going to talk about managing transaction logs. Now this is a really big part of what we do because there are so many different transactions of so many different sizes. If you don't keep track of your transaction logs and how much they're filling up, then you could get in real trouble. It's also really important for you to understand the nature of how your transaction logs work, especially with the different recovery models. Let's go ahead and break out into some demos and I'll show you what I'm talking about. Okay, we're back in our VM in Management Studio. I'm going to create a database called log test. Let me just go ahead and run that up the flagpole right here. There we go. 5, it'll only take a few seconds. Excellent. Now, I'm going to set the recovery mode to simple. Well, that's where we're going to start. I'm going to come down here a little bit. I'm going to create a table in that database, and then I'm going to go ahead and switch to a different database so I don't have any open transactions inside of there, any open connections. There we go. Now, let's take a look at what we've got. I'm going to break out to this other window right here. Let's take a look at what we've got. First, let's look at SQLperf log space. And what we got is we've got a log file that's about a meg in size and about 37% full. And if we look here in sys.databases, we can see here that the recovery model is set to simple and the log reuse weight description is set to nothing. I'm going to talk more about the log reuse weight description here in a couple minutes, but let's go ahead now and set up some transactions, or set up a transaction. So now I've got that. I'm gonna do a large copy, about 800,000 rows, into a table, and I'm gonna begin the transaction, but I'm not gonna commit the transaction just yet, because we wanna look at a couple things here. So I'm gonna begin that transaction. Now while that's going, let's come over here, and you can see here it says executing. So as I do this, you can see that the log test for the log reuse weight description is waiting on an active transaction. Now, even though this is officially finished, see it doesn't say executing anymore, I haven't committed that transaction yet. So it's always going to say active transaction. At the same time, if I go back to log space, you can see now that the log has grown physically to 235 megs and it's being used 99%. So basically we've got a full log. And what this tells me right away is that this log is full and it's about to grow again. Now, where does the problem come in? The problem comes in what if the drive is full or filling up and this is going to grow again? Or what if you just have the max size for this log file set to say 240 meg or 250 megs? You're going to be in trouble, right? So this is where the crux of the problem can come in. When the log starts filling up, it's going to grow the file. And when the file starts getting in a position where it can't grow, then your database is going to crash and you're not going to be able to, you're going to be in a recovery state then. So you really need to understand how the log works with different transactions and the different recovery models, and you need to be able to keep track of potential issues as they come up. And this is one of the ways we do it with SQLperf log space. So now let's go back to the sys.databases table. And let's look at this active transaction. And you notice I still haven't committed yet, right? So what log reuse weight description means is the log is basically circular in nature. It's going to reuse what it can. And in simple mode, if you remember, simple mode says it's going to truncate the log essentially after every transaction. Okay, so let's go ahead and talk about the circular nature of the log because it's really important that you understand this. When you spread out data files across different drives, you can get a performance gain clearly because you're getting to spread out the I/O. But when you spread log files across different drives, you don't get that same performance boost that you did from spreading out the I/O because the log has to be written to sequentially. There's no such thing as striping a log file for performance. If you've got a 5 meg log file on D and a 5 meg log file on C, well, the C, whichever one was written first, let's say that you started on C and then you expanded the log file to D. What that really is that's more or less overflow. It's not exactly how it works. I'll get into that in a second. But what you're looking at here is it's going to write to C. So if you've got a 5 meg log file on C, it's going to write those 5 megs first. and then it's going to spill over onto D, but it's not going to write some on some on C, and then some on D, and then go back to C, and then go back to D. It's not going to stripe the I/O like it does with data files. So if you're looking to expand the log file on different drives, you're doing it solely for space purposes, and you're not doing it for the purpose of increasing the I/O throughput. So does that mean that the log file on D will never be used? If you've got like a bunch of transactions, say you've got a bunch of 2 meg transactions, and you've still got your 5 meg file on C, does that mean that it'll write to the first 2 megs and then truncate the log file because it's in simple mode, and then write those first 2 megs again and write those first 2 and just keep constantly rewriting those first 2 megs? Well, no, not really. What it'll really do is you've got a bunch of sub-log files inside of there. They're called VLFs, or virtual log files. And what happens is it will cycle through those virtual log files. So if you have a 5 meg log file and you write 1 meg transactions, we'll just keep this simple. Well, you're going to write 1 meg transactions. So you're going to write 1 to the first VLF, 1 to the second VLF, 1 to the third VLF, 1 to the fourth, 1 to the fifth. Now, when you're on number 5, all of those other VLFs, 1 through 4 on C, are going to be marked as inactive. So they can be overwritten. But what's going to happen instead of starting back over again at log VLF 1 on the C drive, after you're finished with 5, it's going to roll over to VLF 1 on the D drive, and it's going to roll through all the VLFs on D. Once it's finished with that, then it will go back to C. So you can just think of it as like a rolling window. Sometimes it'll use C, sometimes it'll use D. And in fact, if you're not careful to have your log files on the same level of hard drive, so if you have your primary log file on, say, tier 1, and your spillover log file on, say, tier 3, then you could see some performance differences there, some intermittent performance problems there, and you're not realizing that it's because your log file performs worse when it's on the spillover drive than it is when it's on the main drive. So just know that if you have a log file that spans 2 or 3 drives, right? It's not, you're not going to get the performance gain, so you're not doing it to split the I/O. You're doing it merely for overflow. And 2, it's not going to just reuse that one file again and again and again on that one drive. It's going to cycle through all of those VLFs inside of there. So it's going to go from the C drive to the D drive, then to the E drive if you have one, and then back to the C drive. And of course, that's only if you're in simple mode. If you're in the bulk logged or in full mode, then you have a different scenario there. Your log VLFs aren't being marked inactive until you back up the transaction log. So this is really only for the simple mode. So I'm also kicking around the term of truncate. I'm telling you that after every transaction, the transaction itself is truncated out of the log. That's really kind of a misnomer. We use that as an idiom, but nothing is really truncated. What really happens is that portion of the log, while the transaction is going on, is active, which means that it can't be truncated. And as soon as the transaction finishes, that transaction's portion of the log gets marked inactive, which basically just tells SQL that it can overwrite it. So it never actually deletes anything out of the log as much as it just sets it to be able to be overwritten. It's a lot like the way the hard drive works, right? Windows does the exact same thing. When you delete a file, say you go delete a Word doc, it doesn't go and delete that file, it just marks it as able to be overwritten. That's why you have these products out there that you're able to go back and get files that you've deleted. It's because the files are never gone. They're just hidden from you, and the OS knows that it can overwrite them if it needs to. So the SQL log works a lot the same way. When your transaction finishes, it doesn't actually leave the log, it just gets marked as able to be overwritten, and then it gets overwritten when SQL needs to. However, that doesn't stop everybody from saying that the log gets truncated anyway, because, idiomatically that's kind of what happens. So anyway, now that I've explained that to you, and remember we're in simple mode, and I'm going to drive this home again and again and again, because you really need to understand this. So if I say it a few times, forgive me if you've already absorbed it, but this is the kind of thing that you really need to hear over and over. So remember, in simple mode, after every single transaction, it's going to truncate that transaction log. So now let me refresh this again. See, we're still waiting on that active transaction. because that portion is still active because I haven't committed the transaction yet. So let's go ahead and commit our transaction. There we go. Okay, I've committed the transaction. Now what does this say? It says it's waiting on nothing, right? Because that portion has been marked inactive. Now let's go ahead and look at our log space. And as you can see, the file itself is still 235, but it's back down to 2.5%. So there's a little bit of overhead in there. We didn't go back down to, what was it, 0.9% or whatever it was before. But anyway, so we're at 2.5% of 235 megs. And one important thing to notice here is that this column right here represents the size of the log files on the hard drive. So the files, the combined log files, and in this case there's only one of them, is 235 megs. And you notice that when you truncate the log, it doesn't shrink the file back. So you can have a file that's 60 gigs and mostly empty. Okay, so that's simple mode. Let's go ahead and do this entire thing over again in full mode and see what happens. This is where you're actually going to see the difference between the two recovery models. So let's drop our database. I want to start from scratch on each one of these, just so you can see I'm not cheating. Oops, there we go. Create the database. Should only take a few seconds. There we go. Let's go ahead and set it to full this time. Yep, set it to full. I'm going to come over here and check just to make sure it's in full. There we go. And it is in full, and it is waiting for nothing. Perfect. Let's go back here. Now I'm going to create the table and switch to the right database again. Alrighty. Come back here. Now let's look at our log space. You can see here that we're at 37% of 1 meg, so it's the exact same thing it was before. Now, let's go ahead and start up our transaction. And again, we're not going to commit just yet. There we go. And we're still uncommitted, so let's come over here and check out what we're looking at. Let's look at our log space first. We're at 99% of 235. We got the exact same thing, so nothing has changed. And now we're waiting on an active transaction. We're in full, so nothing has changed there either. So now let's go back and commit our transaction. And if I'm right, and I'm explaining this properly, being in full mode means that you won't be able to truncate the transaction log until you take a full backup. So this should go from active transaction to waiting on a log backup, because it's not going to be able to mark those portions inactive until you back up the log. That's what full mode means. It means full recovery mode. And I think that gets overlooked sometimes, the fact that and I'm going to say that again very slowly, it's full recovery mode. So what that means is that you want to fully protect yourself, that every single thing that happens in that database, every single modification that happens in that database, you want a record of. And there's no way that you can get a record of those if you're throwing transactions away out of the log. So in order to throw those transactions away in full recovery mode, you have to have done something with them. And the only thing you can do with them is to back them up. So you have to take a log backup in order to truncate any transactions out of your log in full mode. So once we commit this transaction, since it's in full mode, it'll go from active transaction to log backup, because we haven't taken a log backup yet. Now let's go ahead and commit this guy. There we go. Now let's take a look. Oh, here we go. Now let's take a look at that. And it went back to nothing. Now, why did it go back to nothing? Because I just gave you this nice big lecture and even repeated myself very slowly that you can't truncate transactions when you're in full mode without a log backup. Let's go ahead and take a look at this. There we go. And you can see that we're still at 235, but we've gone back down to 2.5%. Why did it do that? Well, the reason it did that is because we didn't take a full backup after we created our database. Remember, log backups, they only back up log activity, and you can't restore logs without having a full backup to restore it from. So when you have a database in full mode that hasn't had a full backup, it gets thrown into what we call pseudo simple mode, and it behaves exactly like simple mode. If you see that behavior where you're just not able to keep transactions in your log even though it's in full mode, the problem is it's because you haven't had a full backup yet. And of course your log backups are going to fail too. You will not be able to take a log backup when you're in this pseudo simple mode because SQL knows that it hasn't had a full backup, so even the log backups are going to fail. So that's why we went from active transaction to nothing instead of going from active transaction to log backup, because we haven't taken a full backup yet. Now let's go ahead and do that. Well, taking a full backup now isn't going to do us any good. Let's start this entire scenario over, drop the database, and I'm going to breeze through it a little bit more. You've seen all of this now a couple times actually. So I'm going to set this to full mode. There we go. I'm going to go check that it's in full mode because I just always like to check, make sure I hit the right buttons. There we go. It's in full mode. Perfect. So now I'm going to go ahead and create my table and get it in the right database like I did before. There we go. Perfect. Now I'm going to go take my full backup. Only takes a couple seconds. There we go. Now that my full backup is there, let's go ahead and inspect this a little bit too. I'm at 41% now because I added that table, right? So I've got a little tiny bit of overhead in there now. So now that I've got my database backed up, now I can start my transaction. Okay, come up here, begin tran. There we go. Now you're going to notice something a little bit different too. Now as I come here, it says databases. I'm going to say it already says it's waiting for a log backup, and that's because even though it's in mid-transaction, it is at least waiting on a backup because there has been log activity. So it is waiting on a full backup. Maybe not for this transaction, but it is waiting on a log backup to be able to truncate. Let's look at the log space again. You can see here again we're at 235. We're at 99% and 235. Nothing wrong with that. Now let's commit our transaction. There we go. Let's take a log backup. It'll take just a couple seconds here. There we go. Okay, now let's go back and look at our table. We'll see databases. And you can see that now it's waiting on nothing. And it's back to 2.5% at 235. So you can see the difference between simple mode and full mode. Simple mode truncates it after every transaction, and full mode didn't truncate it until after I took the log backup, and it stayed in that log backup state until I backed up the log, and then it went to nothing. And of course, if you don't take a full backup, even in full mode, you're going to be thrown in pseudo simple mode, and it's going to act just like a database in simple recovery. So okay, I hope that sunk in. I hope I explained that well enough. Thanks for watching, and I hope to see you in the next lesson.